Miss Johnson's learning nap time. Miss Johnson's learning nap time, where we dream about things like avocados or science, and where we dream about things like snoring and science, 'cause why? Miss Johnson's learning nap time. Oh, hello students. I was just enjoying some great nap time, snuggled up in these thick blankets and thinking about, in my dreams, conductors and insulators, thermal properties of objects. I feel like I was thinking about avocados. I don't know. So, what are thermal properties of things, and specifically, what are conductors and insulators? Let's take a guess. Actually, let's learn. So, everything we know has a capacity for either transferring heat, because heat is kinetic energy and can move either through objects by slower molecules bumping into faster molecules, slower molecules bumping into faster molecules, so on and so on. Wait, that doesn't sound right. That's not right. Faster molecules bumping into slower molecules, faster molecules bumping into slower molecules, or heat moving from a warmer area to a colder area. So, we know that happens because thermal energy is one of the many forms of kinetic energy we've studied. When those molecules start moving faster and heat is able to travel through, thermal energy is able to travel through. Remember, heat is actually just that act of traveling. Heat is the transfer of thermal energy. When that happens, and it happens very quickly and can move through something very quickly, we call that substance a conductor. It means that it allows heat to transfer really quickly, thermal energy to pass through quickly, because its molecules are very close together. And we talked about in class a little bit about this, with things like metal being a great conductor when we looked at pots and pans. And we didn't talk so much about insulators. Insulators are going to be things that hold heat in. Now, one common misconception that I do want to address very early is the idea that conductors are things that are warm and insulators are things that don't get warm, or that don't, make you think of warmth. Because that's not true. Some of the things that are the best insulators are things that keep us warm. I also want to stress to you that this has nothing to do with flammability. Remember, if you can eat it or set it on fire, that just means it has chemical potential energy. And I can tell you from personal experience, lots of insulators can catch on fire. If we think about styrofoam, it's one of the things that we see used all the time in drink cups and stuff like that to insulate or to keep heat from moving through quickly. It's the opposite of a conductor, and it'll catch on fire really quickly. Usually conductors, they don't catch on fire, or it takes a lot before they will, like extremely high, like surface of the sun level temperatures before they will, because they have to let that thermal energy move through them. So if I were to ask you, what would a sweatshirt and a big cozy comforter be? Let's get back into nap mode here. If I were to ask you, am I surrounded right now by insulators or conductors, what would you say? Okay, for those of you who just said conductors, or who just thought, man, I wish I was curled up there because that looks super comfy, you're right, it is super comfy, but you're wrong. Definitely not conductors. We don't get into super cushy blankets and into sweatshirts and pull those sweatshirts up over our head and get ourselves under the covers. We don't do all of this so that heat will conduct away from us. Remember, it moves from warmer to colder, and our bodies at a euthermic temperature are about 36, 37 degrees centigrade. We do this and we get under these blankets because they are insulators. They're full of air. Air is a great insulator. Heat does not move quickly through air, which is fortunate, because otherwise the heat from the sun would just fry us all where we stand like little chicken nuggets. But we get under blankets and we get into sweatshirts to hold heat in, because heat does not move quickly through these things. It stays with us, and that is what keeps us warm. So, on my scavenger hunt, I could write down blankets and comforters under insulators, and I'd be absolutely right and cozy. And hopefully won't fall asleep before the next segment of the video where I explain these concepts at a little, a little more, it's been a long day. Detail. Okay, so I'm a little more awake now. Just to make sure that you have kind of the gist of your assignment down, you have been given a scavenger hunt to go on. A scavenger hunt that relates to finding things that have different thermal properties. So, we talked about the properties of conduction and insulation, and those are the two we're really going to be focusing on. Specific heat, I'm not going to have you scavenger hunt for that. I'll explain it to you a little bit more in class, but that, we don't have the equipment, or at least I don't, and if you do have the equipment at your house, probably we need to call the police, because that's some high-tech stuff. So, thinking about it, what I want you to do is go around your house, like I'm going to do, and I want you to find 5 things that would be good conductors of heat, meaning that heat would move through them quickly without damaging them, without setting them on fire, without anything like that. Things that will carry heat straight through them. You're going to look for molecules that are packed densely together. You're going to look for things that if you hold it to a heat source, it will also heat up. Usually like bathrooms and kitchens are great places to start with this. I'm outside to show a couple and also to show allergies, but let's take a look at a couple. So out on my horribly sun-damaged back deck, I have a lot of different rocks that I've collected over the years, and these have been sitting in the sun all day. Generally, rocks and stones, and you can see in my backyard I have a lot of rocks and stones, are really pretty okay conductors of heat, some more than others. We know that darker colors, a more smooth crystalline structure, things like that are going to lead to it. So if I come out and I feel these, how am I going to judge what's a good conductor? Well, I'm going to feel which ones feel the warmest. I'm going to pick up this black one that's like very kind of glassy and crystally looking. This is a piece of black tourmaline with some mica at the end, and it feels quite warm after being out in the sun all day. This piece of quartz feels pretty hot. It feels like if I left a piece of glass, ooh, there's a hint out. But if I go over and pick up this just piece of river rock that kind of looks like a vegan sausage patty or something, it stayed pretty cool through the day. It's warm, but it's not super warm. So I wouldn't say, oh, that's a great conductor of heat. All right, and now we're back in Miss Johnson's Learning Kitchen, and it's messy. But hey, I live the toddler life. That's how things go. So the kitchen is a great place to start looking around for conductors and for insulators, especially when we look at things that we use to cook. Because I don't know if you know this, but cooking requires the transfer of heat from one thing to another. So let's take a look. If I'm looking at my stove eye, I know that this surface itself is going to be something that conducts heat very well. It's a glass surface. It has metal coils under it. Tells me that glass also, it looks like it really needs to be cleaned. I promise I do clean it. It just never really looks like it. This is going to be something, and we've seen this trick before. You're probably like, oh, Miss Johnson, you're not going to impress us. But maybe if I do it with 2 eyes at the same time. We see that this conducts really quickly. We see moving right through the metal coils, that heat transfer happening and getting the glass on top super, super hot. So we know here, glass, metal, these are things that are going to be great conductors. But what do we put on the glass and metal? Pans. Here I have a nice, cool pan. And most of our cookware is going to be made out of, I'm going to turn that off for safety's sake. Most of our cookware is going to be made out of metal and or glass. The reason being, metal and glass are such good conductors, and they don't catch fire, because good conductors don't catch fire. So if I put this on and decide to cook something, it's already feeling like it's getting warmer. It should not be very long before I'm able to see something like butter. It seems to be my go-to example. Start to feel the effects of heat as soon as I put it on there. I'm going to flip my light back on. There we go. So, already we see that this is conducting heat to the butter. Now, I want you to notice something interesting with this pan. What's up with the handle? The handle on this pan, I'll go ahead for safety's sake and turn that off, is not metal. The handle is a high-grade silicone. It actually can go in the oven and withstand up to like 425 degrees, I think, before anything bad starts to happen to it. Someday ask me about my hydro flask if you want to know what happens to high-grade silicone when you surpass that temperature. Why is this? I could touch this all day long and it's never going to get warm. If I touch this, it already is at a point where it hurts. That tells me that heat moves very quickly through this. Thermal energy passes through these molecules extremely quickly. But through here, I'm safe. That means that this handle is an insulator. The type of plastic that it's made with is an insulator. And I want you to think about this. These knobs sit over a very, very hot surface all the time. The plastic in them, what do you think? Insulator or conductor? Probably an insulator. Now, most of our cookware, we see the handle being something that's an insulator and the part that goes on the stove being a conductor. This is a little bit different. So what's up with this design? Here we have the insulatory part, the part that's not going to get very hot or carry heat well, being at the bottom of the spatula, and the insulator, the metal, being the handle. So it seems like I should get burned, right? But for this to get warm, what has to happen? Heat has to pass from a hot surface through one object, speed up the molecules in the spatula itself, which you can see it's not doing. I can put my hand on there very comfortably and be just fine, and then reach all the way up the handle. So because I have an insulator here, I'm safe here. Have you ever taken time to look at the side of a refrigerator door? Behold its beauty. No, I'm just kidding. I do want you to look at this though, and notice that even though the outside of our refrigerators are metal, and we usually think of metal as being something that is a conductor, it's a very thin, and I've gotten something on that, oops. It's a very thin little sheet of metal, but it's very thick. What is it covering? What is in between here? The answer is basically air and styrofoam, meaning that this is one giant insulator. Why? It keeps heat from moving into your refrigerator. Heat doesn't move into your refrigerator, and we know that cold wouldn't move out of your refrigerator because that's just not how heat goes. So it keeps thermal energy from moving into your refrigerator, and there we have another insulator. Another great place to spend time thinking about insulators is your closet. So we're looking at my husband's side of the closet because mine's like this. So that's just embarrassing. He's very neat and I am not. When we think about clothing and shoes, what do we really aim for those things to do? Well, A, keep us clothed so that everyone is not scarred for life. And B, we trust them to keep us warm. So when we start looking, we have clothes to keep us warmer and cooler. For example, if we have some kind of outdoorsy clothes, these might actually be fabrics that conduct heat away from your body. They conduct heat away and keep you cooler in the summer. But by the time we get into the winter section, we see all these just thick, warm sweaters. Same on mine, just thick, warm sweaters. These are going to be, just like the blankets we saw at the beginning, insulators. They're going to keep heat in and closer to your body. Heat will not move quickly through these things. Now, again, I do want to point out, insulators are often flammable. But your closet, great place to start thinking about insulation versus conduction. When we look at winter shoes, we usually are looking at things that have thick, kind of foamy, or I don't know if foamy is the right word for a shoe, spongy, squishy layers and that are going to keep our feet very warm. They're going to hold the heat on our feet. Hey, that rhymes. But if we look at a pair of shoes for summer, like just a pair of dress shoes, we're going to see the opposite. We're going to see very thin materials, things that allow heat to move through them more quickly, or no material, more quickly and away from our feet. So as we're looking out at the great big backyard, the great big front yard, well, actually, we haven't really made it to the front yard. As we're looking at the world around us, up at the sky, all of these things, understand that the outdoors is a system of insulators and conductors as well. Animals have to find good insulators to keep themselves warm. We have to have conductors to get heat flow going in a way like that gets weather moving all over. We have surfaces like stone surfaces that make for good conductors and cause the air above them to get warmer. We have grassy surfaces and mountains and hills that make great insulators and cause differentials in heat that just change the weather all around the world. And all of these things make up our world. One thing that we didn't necessarily talk about are coats. Coats, of course, are the ultimate in insulatory fashion. When we think about ways to keep ourselves insulated, just like I was snuggled up in those blankets taking a nap at the beginning of this video, then I had to wake up to teach some science. Whatever. We put on coats in winter to keep ourselves warm. One of the absolute warmest things that you can find in nature, one of the best insulators. And notice, when we're talking about insulators, we're talking about things that don't let heat move very quickly, but we do tend to talk about them as being warm things. Is it styrofoam like in a cooler? No. Is it, I don't know, blankets like the one I was cuddled in? Maybe, depending on what it's stuffed with. But in general, one of the absolute best things you could find to go inside of your coat to keep you warm and to be a great natural insulator is feathers. Come here. Come here. Come here, you little insulators. These floofy feathers. Hey, do you guys want to get turned into coats? These feathers provide amazing insulation to these chickens. They actually help their body heat stay in winter so that they stay nice and toasty. Hi, Alfie. Oh, don't pretend you're camera shy. And then in the summer, they help them keep cool by fluffing up. So, in the meantime, me and these future coats, these wonderful insulators that might one day end up in Miss Johnson's Learning Kitchen, are going to take a little bit of time, enjoy the remnants of solar radiation, and think about our choices and how to avoid getting turned into coats. I'm just kidding. I love them and I would never do that. This is Elfie and Beatrice. Miss Johnson's Learning Chickens. Miss Johnson's Learning Chickens. Miss Johnson's Learning Chickens are awesome. Hey guys, what's up? Chicken butt. Okay guys, bonus time. So, before you are two, I would say equally valuable, but one is precious to me and the other is just a Yeti cup. Two equal in quality, we'll say coffee mugs. Coffee to go mugs. I can carry a hot drink around in them. I can carry a cold drink around in them, and it will stay that way indefinitely. So these are both good insulators. Makes sense when we look at this beautiful piece of work. It's got rubber. It's made from really thick layers of porcelain. Porcelain's not known for being a great conductor. It just looks like something of quality that would keep your drink exactly where it needs to be. So this kind of makes sense. Hey, go Tigers. But here's a question. Yeti is famous for making coolers and for making these cups. However, these cups are made out of metal. Metal, as we know from this experiment, Not known for being a great insulator. In fact, metal is known for being a very good conductor. We've got closely packed molecules. Heat moves just right on through it. So why is it the case that these cups, rather expensive stainless steel cups make such good insulators? I can put a cold drink in there and it'll still be cold in the morning if I fall asleep with it next to me. I can put a hot drink in there and it'll last through at least, I'm just kidding, a hot drink would never last a second period with me. But if I left it alone, it would last till probably second or third period, at least staying warm for several hours. So why does it happen if it's metal? That's a bonus question. It's going to be on your scavenger sheet. I want you to find out about this. I want to know the answer to the mystery of the Yeti cup. And once again, isn't it beautiful? And do your homework. Do your homework. Do your homework. Conduction. Insulation. Scavenger hunt. It's fun. Have a good time. Bye.